Okay, so to answer a couple of your questions here, we'll start with this absolute value question. So when you're taking the absolute value, remember that's the distance from 0. So if I'm less than 12 spaces away from 0, that means I'm somewhere between -12 and +12. So you could think of it that way, as x being somewhere in between -12 and +12, because I'm 12 spaces away. So what you want to do when you solve this, actually there's two ways. Because it's a less than is an and you could write your answer like this with your two values of your two endpoints. Or we could write it as two separate inequalities. So that's what I'm going to do just to show you. 3x minus 3 is less than 12, and I'm running out of space. 3x minus 3 is greater than -12. Make sure that the second one you flip the sign and negative. So it's like you divided by a negative, so you flip the sign and you changed it. So this one over here, I'm going to add 3, divide by 3, x is less than 5. This one I'm going to add 3 and get x is greater than -3. So you're welcome to say x is greater than -3 and x is less than 5. And you could also state this way. X is bigger than -3, x is less than 5. If this had been a greater than question, the rules change completely. Because if it's greater than 12, then that's saying on our number line, the distance is more than 12 units away. So your answer is an or, because it's less than this number or greater than that number, but not the numbers in between. If it's the numbers in between, you can use and. If it's greater, I jokingly say greater, so remember it's or, and less than is and. So this one you would get the same two numbers, but you would get the fact that x was going to be less than -3 or x was going to be greater than 5. So you would go through the same process saying 3x minus 3 is greater than 12 or 3x minus 3 is less than -12. So in the second one you change the sign and make that negative. Okay, I hope that helps. Number 5. So this one we had you do the transformations and the domain and range. The 1/3 is a vertical compression by 1/3. And then of course the -4 is a vertical translation down 4. And those are the only two things that happened there. For our domain, because the original function was an absolute value function, so the domain is all real numbers, -infinity to infinity. The range, notice it didn't reflect, so it's still looking like this. It just went down 4 spaces. So instead of the range being from 0 to infinity, it goes from -4 to infinity. If it flips over, then it starts at -infinity up to this vertex, but it didn't reflect. All right, number 7 was a composition question. So this one we're going to put f of x, all of this, in place of x, in g of x. So here goes. G of f of x equals 3, and now all of this, 2x squared plus 5 plus 2. And we distribute 6x squared plus 15 plus 2, and we simplify. So that's our g of f of x. So if you wanted to, we could practice it the other way, just because we can. What if I was plugging g of x into f of x? So now I'm going to take, we'll use a different color. I'm going to take all of this and substitute it in here in place of x squared. So this time I'm going to say 2, parentheses, 3x plus 2 squared plus 5. Always be careful when you're squaring this, because a lot of people make the mistake of just squaring 3 and squaring 2. So remember, you want to write it twice and FOIL. And don't forget that plus 5 at the end. So here goes. This is 9x squared plus 6x plus 6x plus 4. And then I'll distribute my 2. Let's see, that's 12, so that'll be 24x plus 8 plus 5. And finally, 18x squared plus 24x plus 13. So you're ready for either way. If they asked you for g of f of x, you plug f into g. If they ask you for f of g of x, you plug g into f. Hope that helps. And then there's number 9. The evil number 9. I'll show you what happened. So first I add 19 to both sides, and that gives me 121 equals negative 11 absolute x plus 16. I'm going to divide both sides by negative 11. And it says negative 11 equals absolute x plus 16. Right here, if you notice, can an absolute value ever equal a negative? And the answer is no. So you could stop right here and say no solution. Absolute value cannot equal a negative. If you did continue, you probably got a negative 5 and a negative 27. But those don't work. That's why this happens. So if I plug negative 5 in here, the absolute value of negative 5 plus 16, well, that's the absolute value of 11, which is 11, not negative 11. Same thing with negative 27. If I plug in negative 27 plus 16, I get the absolute value of negative 11, which is again 11. Absolute value is never going to yield a negative answer. So you could stop right here if you noticed, or if you continued, check those answers and make sure they actually work. Good luck.